This is a projectile motion problem. In this problem, you're trying to figure out the velocity the cannon would need to fire to hit a certain location. The location is 350 meters in the X direction and 75 meters in the Y direction, and at 40 degrees is what we know. So we're trying to find out how much velocity would you need. So first thing you do is you get your X and your Y motion. Your X initial is going to be 0. X final is going to be 350. Your velocity for X is going to have to be V cosine 40, because to find X you're going to need cosine because it's adjacent. Then your acceleration in the X direction is going to be 0. We don't know the T. Y motion is going to be Y is initial is 0. Y final is going to be 75 because that's the top of the hill. Your velocity in the Y direction is going to be V sine of 40 because it's opposite, so sine. Acceleration in the Y direction is going to be negative G because the only force that's going to be acting on the ball when it's in flight is gravity. First thing we have to do is plug what we know into this equation, because we're going to have to try to find T. So plug it in, then we get everything to the left side to find T. Take the square root, we get that. Now we work this one out, and we're going to plug T in eventually, but see, we plug in here. This is going to cancel because acceleration is 0. Well, X initial is 0, so that's nothing. Final is 350, so we're going to divide both sides by cosine 40 degrees T. Plug in your numbers, and we find out that the velocity needed to get the cannonball up here is going to be 68.4 newtons.